Hey everyone, welcome on in. Happy Friday. We're going to be starting a new course today, Introduction to Machine Learning with Python and NumPy. You're going to learn all the basics. We're going to go through everything. It's actually kind of a nice refresher for me as well because, there's the basics things that you remember, and all the way to backward propagation, which is the most challenging part of AI and the part that actually makes the AI learn. So we're going to start off with NumPy, and let me get my repository set up here. I've got my Windows set up so that way we can easily, should we change the directory? Yeah, maybe I can I think that's fine. It's fine. All right, git status. We don't have a git, so git init. Create a new GitHub repository here. So that way you can share if you want to have the code. Hey, Clinker Pays, how's it going? Such a nice initiative. Thank you. Hey, Ruchit, good to see you. Welcome on in. Happy Friday. Good to have you guys here. We're going to start our machine learning journey. Let's do it. If you are already familiar with this, then it will be a nice sort of like casual stream for you. Hey, how's it going there, System? Yo, System. Hey. Good to see you. Wow. First like done. Thank you, Ruchit. Thank you very much. All right, let's see. We got our git initialization. We need to do vi. We're going to open up our lesson. So we do lesson -01. Is that like a good, I think that's a good way to start it. There we go. And then we can say Python lesson 01. So we can run it there on the other side of the screen. Something like that. So that makes it real easy. All right. So before we can do any machine learning, basically we have to be comfortable with manipulating arrays and matrices. This is what most systems call tensors. So you've got PyTorch, you've got TensorFlow, you've got Candle, you've got Burn, you've got TinyML, you've got all these frameworks. You've got a lot of frameworks out there, and they all require you to manipulate tensors. And so we're going to do that with a library called NumPy. So I think we need to say import NumPy, import NumPy as MP. You got to type import correctly. Like that. There we go. Hey, Arsalan, good to see ya. Yo, bro. Like done. Thank you. Appreciate it. Good to have you here. Looking forward to some machine learning. So this is going to be, let's type this in here. So this is going to say Introduction to Machine Learning. All right, so this is what we're going to do here. Let's make it pretty as well. Let's make it add some little bit of dashes and things like that. So that way it looks nice. There we go, and copy paste this. There we go. Make it pretty. Excellent. Introduction to Machine Learning. There we go. What are we going to do today? Are we going to see data cleaning today or directly... I even forgot about data cleaning. That's a really big part I didn't even think about. That's not in my lesson plan. Data cleaning is so important. I forgot. Hey, thank you for reminding me. All right, so we do need to add that to the lesson plan. We do. Let me update my notes. All right. Let's see. Let me see 1 second. Let's do lesson data cleaning.py. Okay. All right, there. Done. Lesson 11. Perfect. NumPy is, I don't know. It's set, I don't know. Wait, system? NumPy is just, I also need to spell it properly. NumPy. Call it little NumPy right there. All right, get the next song going there. Okay, perfect. Here we go, you guys. Let's jump into it. So, directly into algorithms. Yes. So, sup, Steven? How's it going there, Retro? Good to see you. Welcome on in. Happy Thursday, Friday. Yo, Steven, howdy. Can you review my project? Sure. Signal Internet. Absolutely. Signal Internet. Let's do it. Hey, Derek. Good to see you. Welcome on in. Good to have you here. All right, you guys. So we're going to do some NumPy stuff here. So first we need to create an array. That's step one. Let's create an array, yeah? What are we doing with MLX? Oh, hey, there we go. We can add some, now then we can go a step further, right? So this is the introduction part. Hey, Quick Fix, good to see you as well. Happy Friday, welcome on in. MLX, we could do some MLX too, yeah? You guys, we've got, so let's add a roadmap here. Let's add a roadmap. Let's see, let's open up this. We'll say roadmap. Maybe we could just call it a readme. Readme.md. All right. Introduction to machine learning and we're gonna have topics. And y'all said we should add a list of topics here. We'll say MLX, right? We'll do MLX. You also said data cleaning. These are things that I haven't added. Data cleaning. If you guys have other topics, let me know. We can add them in. It's the earliest you've ever been to a stream of yours. Whoa! Emo Boa! Hey, all right. Great to have you here. Mohammed, hey, Steven, happy Friday. Let's learn some machine learning today. Let's do it. Introduction to machine learning, you guys, right here. A little bit of introduction to machine learning. So let's do this. Let's do it. Okay. When I learned from a YouTuber, he teach me first NumPy functions, then pandas. Oh, right, pandas, yeah. I like just NumPy. Just stay with NumPy. That's a good one. Data visualization using Matplotlib, Seaborn, and then, Seaborn, which is a Matplotlib add-on, I believe. Teaches algorithms and overfitting and underfitting. Yes, those are good. Okay, let's add that. Let's add it in. Arsalan, good idea. So we could do matplotlib/Seaborn, which is, sort of like a suit. It's an overlay over the top of Matplotlib, right? And then you could do overfitting versus underfitting, right? And we can also talk about vanishing gradients, right? Uh-oh, danger zone, be careful. Gradients can vanish. Collapsing gradient. Well, those are kind of the same. What about gradient explosions? Gradient explosions. Whoa, no, even more dangerous. All right. Let's see. I wanted to introduce you to a cool graphical GUI. Oh, hey, Retro, tell me about it. Called Python with Tinker. Did you know about it? I've not. Google Python TK. What'd you call this? Tincture. Tincture. All right, let's take a look at this. What do we got? What do we got here? Tincture. Oh, Python Tincture. Tincture is a package, a standard Python interface for a GUI toolkit. Oh, so you can make user interfaces. Look at that. I've never seen it before. I've used Tinker, it's really good. Nice. Look at that. Now we can build like real computer systems. Whoa, I feel like I'm going back to the 90s. Check this out. Use mostly Streamlit for applications. Streamlit Python? Is that a thing? Streamlit. Faster way to build and share data apps. Oh, let's look at some images, huh? Streamlit. Ooh, pretty. I like the heat maps, especially when they look like this. They're really pretty. Nice. Very nice. All right, so this will be our topics. So we have a lot more topics in this, though. We've got a lot more. So we're going to do tensor basics. This is what we're going to start with today. We're going to do tensor basics today. Basics. Here we go. And then these are future ideas. These are future topics. Future class topics. Future. Excellent. Excellent. Hello. Hey, Hassan. Good to see you. You also use Tincture? Nice. All right. Gives off that hacker vibe. Yeah. Oh, it does a little bit, right? I'm with you there. 100%. You made your own C2 command center program for exploits. Ooh, hey. Click the button. There you go. Exploit ready at the click of a button. At the click of a button, you guys. All right. What are you building? Hassan, so we're going to do introduction to machine learning. All right, a little bit of introduction to machine learning here. Just a smidgen, right? This is going to cover the topics of tensors today. So we're going to do tensors today, basically arrays. We're going to do array math. We're going to do array math today, making it simple. And if we get a step further, then we'll maybe leak into episode 2, like a little sneak peek into episode 2. That's the plan for today, you guys. All right. So, Steven, we're going to study mathematics behind the algorithms, or just a smidgen. Yeah, we're going to do a smidgen. Yeah, just a little bit, right? Some linear algebra. We'll do a little bit of linear algebra. Just a smidgen. Ooh, a keylogger. Hey, there we go. Hey, how's it going there? Prabhu Susil. Thank you for clicking the hi button. Good to have you here. All right, so let's start off with our array. So let's do our tensor is going to be np.array, and then you can give it a bunch of numbers. Like you can give it a whole bunch of numbers here. Now this is going to be a rank 1 tensor, which is a vector. right? This is what they call a vector. It means it's one-dimensional. And you can say print tensor. And then if we run this, Python lesson 1, you can see it prints out exactly the data that we put into it. Or like that, keylogger with tincture. Can you do that? You probably could, couldn't you? I didn't even think about that. I did not know. I didn't know that you could do that. I assume you could. Just a little bit of keylogger action there. Research is getting close for, okay. Cover, it's, Kraken. Hey, how's it going there, Kraken? How's it going? True assignments using ground truth anchor pool. Oh, good to hear. All right. 105 out of 133. That's pretty good. That's pretty good progress. Yeah, 1 dimension, 2 dimension, multiple dimension. Yes. So this is a vector. Let's call this a vector. Vector, right? Vector. And then we say matrix, which is typically going to be a 2, right? Multiple dimensions here. So let's build a multiple dimension matrix. Looks like that. Here we go. And then we can copy and paste this. So we'll say 4, 5, 6, like that. All right. So this will be a matrix. We can print the matrix. And then we could also print a cube. Although we're not going to do a cube. I'm not going to type that out. We'll do it a different way. Oh no, Prasham, you lost your streak. Hey, Sigma Edits, good to see you. Welcome on in. Happy Friday. Yo, Icy Box, how's it going? Icy Box, a lot. Good evening from Italy. Oh, you're in Italy? Yo, I don't know about Italy. Wait, really, from Italy? ICS, okay. ICS, perfect. So ICX, over there in Italy, I've had some issues with Italy. They took taxes from me. They took taxes. And I don't live in Italy. I don't live there. You guys. Oh, hey, can you, but I mean, if you got the shell, use a keylogger, you can make the tool run on your PC. Yeah, and pipe it through the shell. Anyway, yeah, that's how you do it. Local, I'm just trying to, hello, I know the problem. You do. So you do know. Oh, wow, that's great. ICS. That's, ooh, scikit-learn. Yeah, we should add scikit-learn on here. All right, let's do that. Let's add some scikit-learn. All right, scikit-learn. Add a little bit of scikit-learn in there. 3-dimensional keylogger. Is that a thing? That can't be a thing. There's no way. It's just a simple array. There's different people from different nations. Yeah, there are. Yep, that's how it works. The whole button for one thing. That's not competitive. I mean, why not? Just make a big button. Make a big button. Venice, Italy, because my childhood was played Assassin's Creed. Yeah, there you go. All right, pandas. Well, I mean, if you want pandas, is you like pandas as main? Pandas. Yep, you could do that. A little bit of pandas in there. I mean, in stream. Oh, got it. Okay, Prasham. Building GTA 6. Okay, GTA 6. There we go. We add GTA 6 in there. A little bit of Grand Theft Auto in there. Just a smidgen. Not like a lot, but, you know, a little bit. And you guys think I'm serious? Because I'm not. All right, here we go. Let's open up the next. Let's run this again. Okay. So we will say our vector. Well, oh, there's a thing that you can do here with the F string. Look, this is a pretty neat trick. A pretty neat little trick you could do here with F strings. You can say, oh wait, did that not work? Yeah, we have to do, I believe, this. There we go. And then put your braces, the curly braces around the F string, and put an equal sign in front of it. Or behind it, maybe? What if we do this? All right, so you can print it out regularly, or you could say equals, and it will give you a nice little annotation there. A little bit of a nice annotation there. I like it. Breakfast didn't come yet. Oh no, you're hungry. Jeremy, you got to get that DoorDash. There you go. Get that DoorDash going. Spectral analysis. Hey, Kraken. What is that, Laplacians? Oh, Mr. Jackson, thank you for the gold coin. I appreciate you very much. Hey, that's great. Thank you so much. My gratitudes to you. We're getting started with NumPy here with our introduction to machine learning. We've got, today we're doing tensor basics. We're doing tensor basics today. So we got a vector, right, you guys? The terminology means this is a one-dimensional array. 1D array equals a vector, right? A vector. And then a matrix is a 2D array. Matrix. I know we're going through the basics now, aren't we? Hey, Sergio, good to see you. Welcome on in. Salute, kind sir, Mr. Jackson. Thank you again. Appreciate it. My gratitudes to you. All right, we can do the same f-string treatment over here with our matrix. Right? There we go. Print this out. And it's pretty nice. You can see right here on the screen, we've got vector, which is a 1D array, and a matrix is a 2D array. Right here, a little bit of 2D arrays right there, yeah? We can swap your face frame and code because live comments are hiding the code. Oh, wait, are they? No, wait. Oh, the code, yeah, on the screen. Got it. Yeah, I see what you're saying. I see what you're saying. So you could see the chat. What music are you playing? This is called. What is this called? What is this song? Where'd it go? Where is this? Can we zoom out here? Welcome Again by Jinlu. Welcome Again by Jinlu. I like this song. It's one I always play it at the beginning of every stream. At every stream. Let's see here. I'll go over here. So there is a way. Same thing, yeah. Hassan. All right. Good to hear it. Oh, hey, floating heart. Oh, but very nice, Jeremy. Thank you. So there is a way to on your phone, just click the triple dot or bar on your phone, and it will give you the ability to hide the what do you call it? The chat. You could hide the chat. So that's a good way to do it. You could hide the chat, right? So check this out. Pretty neat. Triple bar. I don't know if you can see it very well, but there's a triple bar at triple dot at the top of the screen. Click that. And then scroll down to the live chat, and then you click the little thing right there. Boop. And the chat goes away and you get a full screen. You could do that. That's one option. That could be something that you do. You could absolutely do that. For sure. Thanks. Yeah, absolutely. So you're Stephen Hawking of computer science. Son, I mean, somewhat. Not really. Stephen Hawking's like a legend, right? A legend. You're teaching real. Yes, really teaching this time. Yeah, Shaggy. Hey, good to see you, Shaggy. Hey, I see your comments. I see your comments when you post those. I see them. It's good to have you here, Shaggy. Oh, hey, Slick. Hey, Slick So Sick. How's it going? Checking in real quick. Going to sleep from San Francisco. Wait, you're going to sleep San Francisco. It's the morning time right now. You should be waking up. You should be waking up. All right. Kraken, it's a way to analyze different dynamics over function scatter data. Oh, okay. That sounds cool. We should try that out. Much love, Jeremy. Thank you very much. Appreciate you. Shaggy, nice. Gonna upload these videos to your channel. Long form, yes. They will be long form, absolutely. Absolutely. You can hide the chat. Change my life. Hey, there you go, Kraken. Thanks, worked. All right, good to hear it. That's so cool, nice. Probably up all night. Yep, that makes sense. Up all night coding. Hey, let's go, Draco. Welcome on in. Good to have you here. Happy Friday. We're building machine learning introduction today. We're going to teach you how to do machine learning. We're starting off 1D, 2D matrices, and we're going to mess around with them for a little bit. Have a good day. Opposite time schedule sounds good. Sounds good. 3 dimensions. Okay, we'll do 3 dimensions. Let's do 3. All right, you asked for it, so we're going to do 3 now. We'll do 3. All right, so it gets a little bit trickier, right? So we got to indent here. We got to do another array. There we go. There we go. We'll go, my goodness. This is what we're going to do. This is what we are going to do. Increment to 4, 5, and 6. You said it. You said it. So there's 1, 2, 3, 4, 5, 6. And then we'll go another one here. And now we are in a 3D world. So this will be 7, 8, 9, 10, 11, and 12. Right? Does that look correct? Does that look right? So this is a cube. I call it a cube. I don't know what else you call it, right? 3D array equals, what do you call it? What do you call it? 3 dimensions, yeah. What do you call that? Stephen Hawking, computer science, Hassan. I don't know, maybe. I don't, we're just here on the planet. Why is there GTA 6 in the future class? You saw that? Nom nom. Norm nom, you're paying attention, Norm nom. I'm the one who introduced that topic, GTA 6. Yep, there you go. 3D vector, okay. We'll call it is it a 3D vector? Oh, because a vector is a 1D array, right? Vector is 1D array. Okay, there we go. Oh wait, let's go to the next one. There we go. Okay, perfect. Okay. 3D vector time. 3D, I don't know, it's like a cube. I'm gonna call it a cube. I call it a cube. It's a 3D vector in air quotes, like roughly, right? A lot of scrolling of the brain, nourishing stream. Hey, Neil, thank you. Good to have you here. Happy Friday. Welcome on in. We're going to be learning some things today. We're going to learn some introduction, tensor basics today. So we're going to create multiple matrices, and then we're going to show you different ways to create matrices today. That's what the plan is. We got a plan, you guys. All right. So now let's print out the cube, yeah? Print f string cube equals, there we go. Print that out right there. Yo, Silver Star Hassan, thank you very much. My gratitudes to you. Good to have you here. Happy Friday. Thank you very much. You know what? That reminds me of something. That reminds me of programming. Hey. All right. Rox, good to see you. Welcome on. Good evening, good morning. All right, let's run this again. All right, so now you get this weird looking thing going on. Whoa, Joseph. Hey. Thank you also for the star. Whoa, you guys are very nice to me today. Thank you very much. My gratitudes to you guys. You guys are so nice. You're very nice. Look at that. Look at that. All right, let's print this out without doing the fanciness. And if you do this, it looks a little bit better. It looks a little bit better. Thank you again, you guys, for the stars. It looks somewhat better. 3D, 2D, and 1D. Where's the cube? I know, right? It should look like a cube. Shouldn't it? This is what it looks like in math terms, in the math world, right? In the math world, it looks like this. The good news is we did it by hand manually. We can do it differently. There's a bunch of fun approaches to do this. Let's build more. Let's build more, yeah? So, let's see here. Control W up, Control W plus. There we go. Control W 10 minus. Here we go. I think we can do that. Nah, that's too much. That's too much here. Let's keep it centered. I think that's fair. We'll keep it centered. All right, introduction machine learning. There we go. Print a 3D star. 3D star. Well, that would take a little bit more time. We could do that. Yo, Druvin. Hey, thank you for subscribing and joining the right channel for software engineering. Good to have you guys here. We are building machine learning from scratch today. We're going to be doing a lot of machine learning introductions. If you guys don't know who I am, my name is Stephen Blum. I am the CTO co-founder at PubNub. We raised 134 million. We're at Series E. Over 1 billion devices on my network today. More patents, so many patents, and I've been doing this for many years now in tech professionally, making, actually in the field. Yeah, and if you want, all my patents are on my page here. You can scroll down and find all my patents here. Right there. Good to have you guys here. We're building an introduction. That's awesome, Kraken. Thank you. Hey. Yeah, we've been doing this for a while. I've got PubNub is my company. I've been doing PubNub for over a decade now. We do in-app communication for mobile games, right? If you ever played games and you played with other people on your phone, right? On your phone, then it will be using my technology probably. You've probably already used my technology. Hey, Sergio, in the box. Wait, what do you do? I like that. Hassan, thank you for the 100. Whoa, hey, you guys. This is great. My gratitudes. Thank you very much. So if you've ever ordered food, hello, man, Krishna. Good to see you, Krishna. Good to see you. Welcome on in. Wow, Swiggy uses PubNum. Yes, indeed. Yep. So if you've ever ordered food on Swiggy, you know what the deal is. You know what it is. You just program every day to be good? Yes, exactly. Statistics. Wait, statics hooks. Statics, yes. Exactly. That's what we do. Can PubNum be used in an error logging way to key? Yes, I use that way a lot. I do. That's one of the use cases. And when there's an error, it pings the dev. Yes, you could do that too. Yeah, it's all notifications, all real time. Read your message, quick fix. Oh, make a poll who has addiction to doom scrolling. Okay, let's do it. Let's do it. Start a poll. All right. I am addicted to doom scrolling. Yes or no? Yes or no? I am. Me. I am for sure, you guys. I do that a lot. Every day, all day. I'm fine with it too. I'm fine with that. Dude, so, all right. So let's see if we can go to the next phase here. We're going to look how to make new, so we can say, let's see here. Let's do print cube.shape. So since this is a NumPy array or a tensor, basically it's a tensor, right? You can print the shape, and that's going to give you information about the dimensions of this system, right? So you can see it's a cube right here. So it says there's 3 dimensions with 2 by 2 by 3. So that's basically a cube right there. Hey SSH, good to see ya. Welcome on in. A lot of tech forums are so rude to noobs. Oh no, that's terrible. What are your thoughts about it? I think we should all be very generous and helpful to each other. I think that's a good way to go about it, because hey, everyone's learning. We're all trying to learn, and there's, it's a struggle. It really is a struggle to learn. Some of the best tech forums you like, I've run into very, the docs. I like the docs where there's no tech forums. Yeah, I've had okay time with Stack Overflow and a couple other places, though I know other people have not. Hey, son, again. Hey, another star. Thank you very much. My gratitudes to you. This is great, you guys. Thank you. Hey, son. My gratitudes. You're so great. 3D is simply good, but it is otgood.net, and there's some good languages. I forgot the name. Oh, I don't know either. I'm not familiar with it. I know .net, and I've used C#, and I've done, ASP, server pages and things like that. But that was a long time ago. That was a while ago. So if you print out the shape, let's print out the shape of all of our tensors, yeah? Let's do every single one. All right, so we're gonna do matrix. Let's bring the matrix back over here. And then we're going to print out the shape of the matrix as well. So you can see matrix, and we'll say matrix.shape, right? We've got the matrix and matrix shape. We'll do the same thing with the vector. A little bit of vector in here. All right, print this as a dot shape. So this is a thing that you can do. It's really necessary in debugging. So we can see that the shape is a 1 dimension, single dimension right there. And it's oh, hey, Silver Star by Joseph. Thank you very much. My gratitudes to you. This is a really good Friday, you guys. We're doing great. Good Friday today. Thank you very much. Oh, you guys are great. Oh, when you can find all the CTOs. Wait, where you can find all the CTOs. What? You guys are looking for a security architect engineer. Oh, Kraken, yes, we are looking for, so say PubNub careers, and you go over here, scroll down to the bottom. We are looking for, let's see here. Wait, did I, oh, PubNub careers. That's the homepage. Careers. There we go. Go into the actual career page. Do we have where to go? It's not listed anymore. Here, I know how to find it though. I know how to find it. It's at the bottom. All right, so look for careers right here. And then you scroll down and we have currently, oh wait, look at that. We got some jobs. Right now in engineering, we have an open role for Rust. So if you're a Rust engineer, come and talk to us. Come and talk to us, you guys. You read half the message. I did, Rox. Where you find all the CTOs. Wait, did you say it's, oh, yes. Oh, some nice Python. Let's go. Hey, Foodoo. Yeah, we're doing some Python. We're going to do some introduction to machine learning today. Some introduction to machine learning. All right, you guys. 3D is simply good, but it is OT good. Okay, I'm just trying to see if I missed any of your chats, you guys. If I missed your chat, let me know. Hey, SSH! A lot of tech forums, yes. Okay. My favorite tech forum. After a long time, now I'm learning JavaScript. Whoa, Shuck, no way. GM! Hey, thank you for subscribing, GM! Welcome on in. Good to have you here. You joined the right channel for software engineering. We're currently covering a topic today on introduction to machine learning. That's what we're doing right now. Introduction to machine learning, you guys. That's the plan. All right. So what do we got going on here? We need to cover, so we print this out. We showed you the ranks and the shapes. So you can see here, let's see here, right around here. This 2D matrix has a shape with 2 by 3, right? So you can see the shape's 2 by 3. This is necessary for when you want to iterate over arrays, things like that. It's also good for debugging. So this is going to be one of your most favorite methods to use when you're in a tough situation. The dot shape right there. You want to use dot shape. You can also check the data type, right? D type. And the D type will be the same for all of these. So let's check all the D types, yeah? Of every single one. See what the D type looks like. It should say float, right? You got some floats in there. A little bit of floating. Right there from the beginning, yes. From the beginning, you got it. If you wasn't a US based, if it wasn't US based, oh, company would be great. Oh, Harry, yeah. I value my downtime and only work 8 hours per day though. Hey, you know what? You can do that now if you just have the computer write the code for you, which is kind of what we're looking for. People to drive the AI. My upcoming course topics, machine learning, Hassan. All right, good to hear it. Search 2000 3D matrix language. Is that a thing? Is that a thing? All right, Google, you said 2000 3D matrix language. Did I spell that right? Is that a thing? Let me type this, let me correctly search for this here. All right. 3D matrix. All right, 1 second. I've got an idea. There we go. Perfect. Okay. Whoops. Okay. All right. 3D matrix typically refers to, yeah, well, that's not what I thought it was. Oh, hey, son, another silver star. All right. I feel like we're getting an A plus in class. How are you? I'm good. Computer vision, good to have you here. Thank you. Rust not at the moment, most likely. Hope you find some good candidates. Okay, yeah, thank you. Yep, so this is currently, we're looking for a Rust engineer. All of our network is written in Rust. Now, we still have one component written in C. Hey, don't worry. Don't worry. We're rewriting it in Rust. Yeah, we are. We're almost done. We're almost done with it. Nearly complete, you guys. All right, let's do some more. Let's do, hey, Joe, are you like C? I like C too. I was really sad that we replaced it with C, but you know what we did. Hey, the sparkles, Joseph, thank you very much. My gratitude to you. You guys are so nice today. Hey, Kyle, good to see you. Welcome on in. Happy Friday. Good to have you here, Kyle. I'm really excited about what you're working on. I like investing and working with API companies, and it sounded like you're kind of thinking, doing some API business, maybe? A little bit of API business? That sounds really exciting. It does. I know that business. I know it because that's what I do. That's my business. It's great. It's really exciting. All right. So we can also get the data type, which is what we did. Whoop, we already did that. All right. Scroll over here. So we got our float 64 and all of our data shows nice and clean there. Looks good to me. Looks great. Okay. Let's keep on going, you guys. Let's go to the next step. So we want to do next. Let's show you how to generate. Let's generate matrices now. So you don't have to manually type in all your numbers when you're doing this. You can generate them. All right. So let's do this. Let's generate our matrices. Let's do that. All right. So you could say generate tensors. You can generate tensors. You got a bunch of numbers on a page, speed, insights today. Oh, those are really good numbers because that's out of 100, right? 99, almost 100%. Nice. Actix Web API. Hey, there you go. A little bit of Rust crate for you guys. If you're not familiar, Actix is a web server framework for Rust. It's it's been around for a long time. It's been around for a long time. We've built some of our APIs in Actix. We've also built with Axum and Pingora and a couple others. Will you do this basics mix side by side with NumPy? Derek, will you do the basics for mix side by side with NumPy? I mean, kind of, that's what we're doing right now. It's all NumPy. All NumPy, all day, every day. Hey, how's it going there? Dung Hung Gamer, good to see you. Hello, welcome on in. Happy Friday. We're currently working on some introduction to machine learning. MLX, not mix. Oh, MLX, got it. Yeah, so this is idea on future class. So we need to get through the basics first, and then we'll get into some MLX maybe. We can do some PyTorch, right? A little bit of PyTorch in there. I like those. Those are good. Those are good, you guys. Feels kind of like hacking into the me who's the medical guy. Oh, really? No way. So why PubNub when I can just set it up myself better and according to my own specs in less than 1 hour and go? If you want. So yeah, you can actually do that. That's actually a good approach. So what we've done is we've built the message network for you, so that way you don't have to worry about any of the uptime, because we've got redundancy spread across the entire planet. So we've deployed all of our code, all of our Rust code for communications APIs in containers in Kubernetes in all of Amazon's data centers. You connect to the closest data center with your device, and every time you send a message into our network, we replicate it 30 times. Basically, we're guaranteeing that your data is available. So for redundancy and deliverability, we're number one in the world right now. We are PubNub. PubNub is number one in message real-time platform. We are. That's us. That's our business. We've been doing this for a long time. So if you need that reliability, that's what we're here for. Can you hack Wi-Fi? Yes. Yes. GTA future class there. I know, right? You saw it right there. Kubernetes cluster also have redundancy. Yep, you could. Deliverability is also not an issue. See, Harry, you know how to do it. Yeah, you know how to do it. You've done this before. So yeah, if you have the expertise and you want to own it and host it yourself, you absolutely can do that. It's up to you. It's up to you. Nice, you deployed your EKS globally. So we're basically like a CDN for messaging. So Harry, if you wanted like a CDN style communication, that's what we do. Like content delivery network, but for messaging. That's where we have that one level up. You built backbone infra. Just writing some things in Rust using OpenSSL and Rust TLS. Ooh, nice, Rust TLS for communication thing. Very nice, ICS. Very nice. Garrett, wait, hold on. Jercotton. Oh, Jercotton Kate. Hey, how's it going? Welcome on in. Jercotton Kate. You built a backbone infra. Basically, yeah. So we've got a global network spread out, meant for communication, for games, delivery, guarantee. Terraform? Yes, Terraform. And Grunt as well. TerraGrunt as well. Who are your competitors? Yeah, all right, so you go to Google, say PubNub competitors. Competitors. You can see the AI will give you some answers here. All right, you got some answers here. So, yep, you got Ably, Pusher, Socket.io, which is open source. And there's a couple others. Sendbird, Stream, Mirror, Comment. I don't know about Mirrorfly. I don't know about these guys. Do you guys do Flux? What is Flux? I mean, maybe. I'm probably not, but what is Flux? Kraken, what is Flux? I don't think so. Send a picture in general chat. Okay, let's take a look. General. Hey, look at that. What are we looking at? Report from, performance. 100. Ooh, that's green. Oh, accessibility, best practice SEO, and you need a little bit of a Flux CD probably. Oh, for continuous delivery. Got it. We do Concourse and, how do you use Concourse? Concourse and Argo. Those are what we do. And of course, like a little bit of GitHub actions in there as well. Yep. All right. Let's see. Okay, let's get back to our introduction to machine learning, guys. Are you guys ready? So let's see. So we can also make some tensors without having to type in the numbers directly. So let's do that really quick. So there is a zeros, np.zeros, and it lets you specify the dimensionality. So let's say it's a one-dimensional vector with 5 zeros in it. So you can say print zeros, and I'm going to hide some of these guys here. Let's hide these guys for now, so that way we can see a little bit better on the screen. Looking good, looking good. Okay, so when I run this, you'll see that created a very quick and easy array with just a bunch of zeros. Right there. Simple and easy, right? Still working on it? Nice, Kyle. Happy for now? Excellent. Gerko is your first name? Gerk Dutch G. Okay, I'm good. All right, good to hear. I hope you're too. I'm good, thank you. Intercoming machine learning more and more these days. Yeah, it's an important topic. We should all know. We're doing all the basics. We're doing the basics. We're starting very small, keeping it simple. I'm going to try to keep it as simple as possible, and we're going to stay in software world. We will talk a little bit about the algorithms and the math behind it, just a smidge. Mostly we'll stay in the software world. Hey, Gloomy, welcome on in. Happy Friday. No worries, you're here. Fluxix GitOps solutions. Oh, got it. Containers directly 101. All right. Every change in your production repo is directly reflected. That sounds excellent. I kind of like that because that's a lot simpler. That keeps things a lot simple. I like simplicity. That's one of my things. I like it. Maybe it's wait, okay, I see. That's what you got. Forgive you. Are tensors some kind of spatial coordinates? Yes. There's also, you can think of them as spatial coordinates. Yes. So tensor is basically any data structure, like any kind of data structure with like numbers. Any data structure with numbers. And it can be multiple numbers. It can be even one number. You can make a tensor with a single number. You can do it after learning machine learning. Sounds good. Argo CD is arguably the better of the build in inference interface. Oh, in the interface. Got it. Flux CD is nice for home use. Okay. Sounds good. Next topic. Okay, let's do it. Let's keep going. Oh, hey, Lucky. Hey, how's it going there? Lucky, welcome on in. You're a genius, Stephen. Thank you. Always a pleasure joining your streams. Thank you very much. That's nice. It's great to have you guys here. Fantastic. Let's keep going. We got a lot to do here. All right, so we'll do the next one. We'll do ones. So you can say equals np.ones. And then you can specify you want a bunch of ones. So let's do 10 ones, yeah? We'll say 10 ones, right? And these are tuples. You guys, which means a tuple or a set is just parentheses with a comma, basically. So you can give it a multiple dimensions. Thank you for the party poppers, you guys. So if you say 10 by 10, which is a matrix, you can say a 10 by 10 matrix. So we'll print the ones like this. So we'll have a 10 by 10 matrix. Let's see what that looks like. There you go. See, now we're making a big number, right? Big number. And it can get even bigger from here. You're starting to see the power. You're starting to see it. The more genius are, the more love simplicity. Yes. Hey, Rox. I mean, that's very nice to say. Yes. I also at the same time, yes, you appreciate the simplicity because it is necessary for maintenance, longevity, and ability to maintain. Make it easy to modify. Simplicity is the way to win. It depends on what your project needs. That is also true for CI/CD. What does your project need, you guys? So this is neat. I like this. So you got a bunch of ones there. Okay. What else can we do? We can also do a range. So let's go. Let's do more. Let's keep going. So more generating tensors. Okay. Even more tensors. All right. So we could do. What do we want to do here? Let's do an A range. A range equals a np.arange, and then we pass in a tuple, and we can say 2 by 2 by 2. See what that looks like. Print a range. No, not array, a range. There we go. And this is going to give you a range array. Basically, that's what it stands for. Let's see, it stands for array range, like that. I think. I am pretty sure. Let's see here. Oh wait, sorry, missed some of your message, you guys. Flux CD turning works on your machine into broken everywhere automatically. Works on my machine, yeah, exactly. The common arguments, like, hey, you guys, it works on my machine. It works perfectly fine on my machine. Time over, not everyone needs monolithic solutions. That's also true, yeah. I'm with you on that. Let's see here. Here we go, okay. Subtraction and removing fluff. Exactly, Kyle, exactly. Yep, addictive process for exploring and innovation. And then you got a, yep. Almost always need an interface. Yeah, for developer board. Weaveworks. Oh, I've not used that before. It's a nightmare though, it is. Never gets on the devs board in my experience as a senior consultant. Flux CD, yeah, I barely even heard of it myself. Barely even heard of it. Okay, so what is C the A range? I did it wrong. A range scalar arguments expects instead of a tuple. Oh, so it doesn't want the tuple. It wants it regular. Okay, fine, sure. We can do that, not a problem. That's really weird, but okay. Oh, I know, because specifically it's gonna give us what the step is. So 0 to 10 to, let's see here, let's try this. So this is gonna say the start and end and how many steps. So 1, 2, 3, 4, 5. All right, what happens if we do 5? 0, 10 by 5, what does that look like? So it goes to 0 to 5, right. And then we can also say 1, so that will be in a range between 0 and 10 with a step of 1, right? So let's try that. So you get an array between 0 and 9, right? I like this. All right, can you do a fraction? Can you do 0.5? Yeah, you can, look at that. Can we do 0.1, so we get 100? Yes, you can, look at that. Let's do a really big number now. Let's make it big. Yeah, complexity right there. All right, so we can bring this back down to 2. So this lets you create a range, which is an array filled with the numbers based on your input. So we can say 0 to 100 and we step 10. So we'll have 10 elements going from 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and let's see here, right there. Boom, looks good to me. If you want another 0, we can do even more zeros. Just a smidgen more zeros. Whoop, whoop, here we go, clear it up. Now your numbers are even bigger. All right, so that's A range. Now we can do a line space, which is gonna be slightly different. Let's see how that's different. So we'll see how a line space is different. It's going to give us a nice even number, I believe. Let's find out. So we'll do 10 by 1 in our A range and look at a line space array. So that's print A range, right? Let's do this, A range. So this is our A range, print, and then we're gonna print a line space. We'll do a line space, which is called lin space, but line space. Okay, lin space equals np.lin space, and it's this. We'll do the same numbers, 10 and 1, right? Let's see how that's different. Print the line space. We'll copy and paste that, so we know this is a line space. Here we go. Bring this down to the bottom. Okay. See what this looks like. Compare the two. Well, you can see there. All right. Let's bring this over here. 5, 1. Well, we'll do like 1, 5. See what this looks like here. Okay. So this created a. Oh, you can see the number of steps. Okay. number of steps between 0. So let's match this now. Let's match this here. So this will be 10 steps between 0 and 10, right? So that gives you a perfect linear line between 0 and 10. So, and you've got 10 elements in there. And also you've got 10 elements here with the A range. So I like line space better because it's going to give you floats. And with those floats, you can do better configurations in future vector math that we'll do in the future. You added a subtractive method visualized in general chat. Oh, hey, let's take a look. A subtractive method. A bunch of food, less food, fast food, all the food, fast food, pizza. Okay, yeah. So you're left with just pizza. That's subtractive. It counts. The poll has 67 brain rot number. Oh, it did for a second. Quick fix. It did for a second. All right, so now what we've done here, you guys, is we've created tensors. We've created tensors that we will be able to use in future math equations, which we're gonna have a good time on that. We're gonna have a good time. Had a lot of fun. All right, so that was tensors. Now let's look at how to manipulate pizzas in different styles. Oh, I did not get that part. Pizza, a different pizza, a slightly different pizza. Now I'm hungry. Kyle, thank you. It's breakfast time, you guys. I'm hungry. Okay. So let's go to our next step here. Let us go into further progress. Let's go to further progress. All right, so that was lesson 1, making arrays. So creating tensors. All right, thank you for the reactions, you guys. Appreciate it. As long as pizza's not with pineapple, avocado, or banana, I'm on board. How about corn? Does corn count? Can you have corn on pizza? Corn on pizza? Yes. Yeah, I think so. I think corn on pizza is perfectly fine. Okay. Let's do this. Okay. All right. So that was creating tensors. Now let's see using tensors in math, with math. All right, so that will be next lesson. We're going to start that now. Lesson 01. Here we go. And we're going to say lesson 02 is going to be using the tensors. All right, with math. A little bit of math there. Corn is a big no in general for you. What? Really? I think corn is amazing. I love corn. Corn is great. I eat corn. I love corn. Okay. So let's do lesson 2 now. Yeah. All right. Open up a new file. Call this lesson 2. Lesson 2. There we go. Okay. Import NumPy as NP. There we go. All right. Introduction to machine learning. Right there. Also, let's commit this to Git. You like corn? Hey, Harry, you like the song? I know the song. The meme song. Blum fruit student wins. Cooking with Steven. Can you use it? My cooking, I don't know if it's that exciting. All I do is chop the vegetable and eat the vegetable. That's it. That's all I do. Sometimes I chop the vegetable and I put it in the oven. Roasted corn's good too. I like roasted corn. Corn on the band. You mean corn on the cob? Is that a thing? You thought it was something with P? I don't know. All right, so Python lesson 2. All right. So we're doing lesson 2 now. Food, I saw you have no mouse mode enabled in Tmux. Oh, yeah. Wait, you could add mouse. There's mouse mode? Yeah, I like no mouse mode. I'm perfectly fine with that. I don't want mouse mode. Lets you highlight text in split pane windows without leaving its borders. Oh, I kind of want that. Although when I do, I just do this, right? I just do this. I like this approach. If I could do that though, and just highlight just inside the pane, that sounds kind of neat. Okay, so set G mouse on. I'm gonna try it. Set, that's G, mouse on. All right, let's try it. Whoa, look at that. Hey, we're getting fancy now. Although it doesn't keep it highlighted. Does it also copy it? Is this also copying it? Yeah, I think it might be copying it. All right, so let's try this. Yeah, it does. It does a copy. It also works, yes. Well, thank you, Foo Dude. I kind of think that's pretty neat. I think that's pretty neat. All right, we learned something new. All right, so vi tmux config allow mouse copy highlight then we say set dash G mouse on. That's it right there, right? That's it. Yo, Foo Dude, thank you, making my life better. All right, there we go. Excellent. Git add, git status, git commit am. All right, so we did lesson 1. Lesson 1 complete. Let's go back over here. Lesson 01 complete. Oh wait, we need to build it. Let's make a repo for this, guys. You had live chat hidden, so got it. Yeah, no worries. I thought I was understood. All right, let's go to GitHub, you guys. Thank you for the party poppers. We're gonna make this repo available to you guys if you're curious about it. New repository. There we go. We'll say Steven. Okay, and we're gonna call this Introduction to Machine Learning. Let's see, Introduction to Machine Learning. All right, public, go. Right there. Embassy for Rust is actually really nice. I've not heard about that. I don't know what that is. I do not know. All right, now we should have, let's see here, right there. Okay. Introduction to Machine Learning topics. Lesson 1, creating tensors. Lesson 2, using tensors with math. That's good. I like that. That's pretty funny. Okay, so this is what we're gonna do now. We're gonna use tensors with math now. Should I come back with a CI/CO reporting? What you're doing here? Oh, I mean, if you want, it's up to you. However you want to do it. Whatever you want to do. Okay, so Python, yeah, a equals mp dot, let's do a line space. No, let's do an a range. So that way we keep numbers like simple and clean. 0 to 5, comma 1, right? And we'll do the same with b. We'll do a b here, right? And maybe yeah, b is fine. And then we'll print this out. Print ab. See what that looks like. Python. Let's see. Lesson 2 here. Python lesson 2. There we go. Okay. So we've got 2 arrays, 2 tensors, right? They're vectors. These are vector tensors. Python, yay! Golden fisherman. Yeah, we're doing some Python, you guys. I love me some Python. Yep, there's even a Python emoticon right there, right? Heart. Let me say underscore Python. There we go. All right, perfect. That would be reporting too. Is reporting a good thing or bad thing? I feel like you're trying to, yeah, I don't know. I don't know. Is that good or bad? What's your thoughts on Zig Bun? Oh, Zig Bun. So was Bun was something, I don't know. There's something, I know there was something along the lines there. Zig maybe have been used for Bun, or was something rewritten happening there, or in order to compile, there's some compilation in there. Zig is, I actually don't know. I only heard about it in passing. Hey, Snot, good to see ya. Welcome on in. Python, yep, we're doing Introduction to Machine Learning because it was the #1 requested thing that we do next. CISO is very important in your opinion. I always program and set up infra defensive. Oh, Harry, yes, okay. Right. Security practices. Yep. CISOs mostly do business budget, hard lifting, almost never technical roles. Oh, right. Okay, so we've got a lot of CISOs in here. Bun was written in Zig, then it was changed to Rust like 2 days ago. Oh, see, I didn't even hear about that. Really? Zig creator is crashing out? No way! I need to watch more on that. Python, SQL, TypeScript, JavaScript are basically all I've ever used. Those are all the necessary. You've got the core languages. Those are the core languages. Everyone should know those. Those are, in my opinion, the core languages. You need to use those by far. All right, let's do some math on these, you guys. A little bit of math there, just a smidgen. Better in Rust. Bun is better in Rust. Zig creator can. Yeah, all right. I'm with you. Any advice you recently? Yes. Any advice to a recently graduate? Yes. Yes, absolutely. Hash. So likely you're looking for a job. Here's the problem. You don't have much experience, right? So there's a common trick that you guys I used myself. It's available in the industry. It's a very common trick. How to get a job, almost guaranteed. Python's boring. Hey, it's necessary. It's a necessary language, I think. But you're right. Like Rust is definitely more exciting because it's dangerous, right? Danger zone. You should make your own torch lib. Oh, that would be fun. Still, yes. All right, we'll do this. Make our own library. Our own tensor library. We could do that as well. That's another good idea. We'll do that. Future classes, you guys. Future classes, right? Future class topics. We'll make our own. We'll use MLX, do some data cleaning, show you PyTorch. We'll do some graphic rendering with charts and graphs, you guys. Talk about some of the common problems that you have. A little bit of scikit-learn, some pandas, some GTA 6. You should make your own. Yes, we're gonna make it. I think it's a good idea. Make it in C++. In C++, maybe. I kind of want to do it in Rust because there is a Rust, a new way to do a function fn in Rust that lets you execute your modules directly. So basically you can define a function that will be triggered when you try to invoke your class instances, your structs. Hey, Rock Brian, good to see you. Rock Brain, you guys, welcome on in. Good morning, y'all. C++ only for leak code. You need experience using the industry. Yeah, that's a good one. No, don't do it in C++. Okay. I want to do it in Rust. I would say Rust because it's pretty neat what you can do with this. And I really want to do that. I want to do that part right there. Hey, I like fishy. It's good to see you. Welcome on in. Happy Friday. We're doing Introduction to Machine Learning, you guys. Let's keep it going. Okay. And if you have any topics that you want to talk, Rust is good too. Nice. Yeah. So if you have any topics that you'd like us to cover, these will be in future streams. We'll add them to the list here. So we got a lot of items. Currently we're on lesson 2. We're going to do a little bit of math with our tensors. So we're going to show you what it looks like when we do some things with these tensors here. Let's do it. All right. So let's run. You can see the output here based on these two arrays. Basically they're tensors. They're vectors. Yeah. Your Rust is similar to C++. Pretty much. Make it in Java? No! Not gonna happen. Not in Java, no. Not in Java, Mr. Hey, how's it going there, Mr. Truffles? Hola, welcome on in. Good to have you here. Teach me Rust gently. My compiler already bullies me enough. Yeah, I know, right? Gloomy traffic. Hey, Steven, happy Friday. Good to see you, Ben Cater. Welcome on in. Good to have you back, Ben Cater. All right, so let's do some math here. Print a plus b, right? To do some a plus b, right? See, this is the neat thing. This is what I really love about NumPy and tensor libraries. They let you do these types of operations. Yes, these are matrices. They are matrices. They're vectors, and you can do simple math. This is the ultimate brilliant part about this right here. Java's gross and resource hog. Yeah, it is. Right? Exactly. Java, no, exactly. Rust for API sounds awesome. Smart. Did you consider Elixir? Ooh, yeah. Get some Erlang in there, right? Erlang with Elixir. We have a lot of stuff to cover over the years, you guys. We got so much time. We're going to cover everything. We'll do some Haskell. We'll do some Elixir. We'll do some more Erlang. We'll do more machine learning, more tech. Java has highlights. Come on. It has its highlights. It's object-oriented. Yeah, right? A string is an object, right? String is an object. It's got that. I can say I appreciate that part about it. I remember that part. Classical inheritance. See what it looks like when we run these together. Okay. So it did what you think it was going to do. When you added these two arrays together, you can see 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6, and 4 plus 4 is 8. You can do more than that, though. You can subtract them from each other. So now they'll be 0, right? All 0, because they are the same matrix. So this A minus A equals 0, right? Under all conditions? Right? I'm pretty sure that's like a proof or something around there. We can also multiply them together. So you can add them and multiply them. So you get some nice little multiplication going on there. And you can do division if you want. Which operating system do you use? I use Darwin. Uname Darwin. Right there. So you can see on my screen it says Darwin, which means I'm running Mac operating system, Mac OS. Not for all numbers? Oh, wait. I guess that's a good point if there's a negative in there. No, right. Maybe. -1 minus -1? What does that equal? What does that equal? Wait, I should know that. Python, -1 minus -1 equals 0. All right. What about -10 minus -10 is going to be 0 as well, right? It's also 0. There's some bit of issue for floats. Oh, yeah. Float math, you guys. Here we go. Make your own tensor library in Rust. Do you plan to import your Rust lib into our Python code? Ooh, we could make it. We could do that. Yeah, you could Python 03, right? Python 03. Gabby is live. Hey, how's it going? Yo, welcome on in. Happy Friday. Good to have you here. We're doing some machine learning basics, you guys. And the poll, it's making the question how many time I have. Okay. All right. What's the next poll we should have, you guys? What's the next poll we should have? All right. Making me question how to use my time. Psychological damage. I like your idea, Foo Dude. We're going to add it to the list. Here we go. All right. So we're going to say Python 03. Import to Python. Right? Python 03 right there. A little bit of a library for a poll. Yeah, exactly. What should we poll next? What should be the next question that we talk about, you guys? The next topic. What should we do? GTA 6. Code with AI? Oh, yeah, let's do it. All right, start a poll. All right. I code with AI or not with AI? Yes, AI coding, please. Or no, I only code by hand. Thank you. Thank you. Wait, only code by hand. Human for the win. FTW for the win. Okay, there we go. Poll's ready to go. Ready to go. Oh, yeah. Total time coding. All right, that's another good one. Only code by hand. All right. Regression model with stats models. Ooh, Seth. All right. Here we go. Regression modeling with stats models. All right. Yep. Actually, we are going to do some basic regression. We are. That's actually part of the lesson plan. So we are going to do some more things here. That's the plan. We will be. Also now coding with AI. Yeah, I do that too. I do code with AI. How should be pace of this lesson? Medium, fast. Good question, Rox. Good question. What could it be? Let me see here. Python lesson 2. Okay. Invalid value encountered in divide because we're dividing by 0. Division by 0. All right, let's increment this. There we go. So we don't do division by 0. All right. So now our arrays look a little bit more simple. A little bit more simple, you guys. I'm reading your data structures analysis and algorithms in C++, and I like it better than Python. Hey, me too. Back in the day, before I knew what Python was, I loved my C++. And I was like, there's no way I'm going to get rid of my curly braces. I love my curly braces. How could I ever possibly live without them? Best of both worlds, AI review is human coder. Hey, yeah, there you go. You combine the two, machine and human together for better. For better, you guys. Make it better. All right, you can also do some pretty interesting things you can do some direct scale. We could also do, check this out, you can also do a, what do you call it? exponent. You can do exponents. A little bit of exponents there. Part about watching you code with AI would be how you approach editing the code and how quickly you can ship small projects. Yeah, you really can. You can ship pretty fast. Really fast. A little bit of exponential math there, you guys. TypeScript 7 just released. Whoa, much faster now. GCA, learning new things every day. See, this is why I'm here, because you guys tell me about these things. Thank you. I've learned so much from you guys. Do you have a GitHub page where I can find all your lessons? Yes, we do. Let me do this real quick. All right, git add, git status, git commit, am, lesson 2. There we go. Push to main branch. Let me throw this on our Discord, you guys. So here is our Discord, lesson 1, lesson 2. Let's go over to our link share. Paste it in to the link share. There you go. There you go. Will most of this course be modeling on time series? Oh yeah. So we didn't even get into the kinds of data that we'll be doing. So yes, time series, features. Basically, yeah, we could do time series, we could do features. There's a lot of different things we could do. So let me see, different data, different models like time series and features. Time series as features. Yeah, you can do that as well. So then you get different kinds of models, right? You can get some LSTMs in there. Beautiful, thanks. Hey, Seth, absolutely. Have you tried Meta's new model, Meta Muse? Is that a model? Wait, I want to learn about this. Hold on. Google Meta Muse? Is that a thing? No. AI, introducing Muse image. Is this it? Oh, it's for images and videos. Oh, very nice. I have not tried it. For video and imaging. Nice. Yeah, I've not used it. It looks great. These are great examples. Woo, look at that. We got some fanciness here. Ooh, it looks real. Oh, we got some food here. I'm getting hungry, you guys. This is great. Anyone had a chance to work in Fable 5? Yes, my team, we've tested it out. We tried it out. It's pretty good. It works. It does what it needs to do. It hasn't really, for us and the kind of work that we do, it achieves the objective. It does what we want it to do. So yes, you can also do a square root and an exponent. So let's do that. So you can do, watch this. You can do np.square root, sqrt, like that. You can do an exponent as well. exp. You can do exponential right there. So let's see what that looks like. Lesson 2. All right. So you get some big numbers there. A little bit big numbers. There you go. Lesson 2 complete. Is it really better for one shot compared to Opus 4.8? So I've found that Fable and Opus 4.8 perform pretty much the same for the kind of work that I do. Whether I'd use Fable or Opus 4.8, it achieves the same outcome. I've not really seen one do better than the other. They seem the same to me. It's just that one is more expensive, right? One's a smidgen more expensive. All right, so that was lesson 2. Let's go on to indexing and slicing next. So today is a really calm and cozy day where we're manipulating tensors. That's what we're doing today. You use Fable 5, but I think it will just stick to the thinking by yourself. Hey, much cheaper and much more learning for you. Yeah, there you go, GCA. Passively coding. Yeah, so that's what I do too. I do that too. Fable 5 improved performance. I heard Anthropic cheating under the hood. They do that regularly. See, it's one of the things is they cheat. They cheat. They give you the different model. They're like, oh, you're using Fable 5, but you're really using something else. You got a lot of mileage in JavaScript page and proxy API helper in a few questions. That thing is fast. Oh, is it? Oh, that's good feedback. Hey, we got a positive feedback there. Nice. Very nice. That's a surprise. Thanks for sharing. Yeah. If we look at last year, AI has become way better. Yeah, it has. I agree with Steven. Fable and Opus 4.8 perform almost the same. Yeah, I'm seeing exactly pretty much the same. Yeah, pretty much the same. Okay, so that was lesson 2. So lesson 3 will be indexing and slicing. Lesson 03, indexing and slicing. This just means that you're going to take pieces from your tensor. I want that part right there. I want this part from the tensor. I don't want that part. I want that part. Then I want this part, just a little bit of that part, right? So we see all of our tensors here. I want just these two numbers here. Just those two, right? Or I want, maybe those two or these two. Things like that. I want just a few things. Let's see here. A set -G mouse off just for now, so that way I can show the screen. So yeah, I want to select these elements or these elements. I want maybe these or maybe just those two. Yeah, little things like that. So we're gonna do some slicing now. Some slicing. Lesson 3. Let's get going. Lesson 3, you guys. Lesson 3. All right. Lesson -03.py. Import NumPy as NP. There we go. A little bit of NumPy as NP. Anyone tried for prototyping solutions for math problems? I've not tried it. I'm curious if anyone in chat has. It's all chaos at Anthropic. The China models are going to open source, and it should be, yeah. See, that's one of the things. They got competitors now, right? They've got competitors, so they're going to have to make theirs better. I like that competition. I'm really grateful for it. Proxy API could help it. All right, pretty common standards. Brainstorming's really clever. Yeah, I like it. I like brainstorming. I like doing the brainstorming. Or something genuinely novel fails to make good decisions. You tried for a novel product development. Fable is not good. It's not. Okay. So TypeScript is slower as JavaScript? Well, TypeScript is JavaScript, right? So TypeScript is slower as it's like as slow as JavaScript. Yeah. As slow as JavaScript. All right, let's do slicing and indexing, you guys. So this is going to be our slicing and indexing. Print. Yes, but it has become faster. Oh, really? Has it become faster? I suppose that's possible. If you only do TypeScript and you do a different engine. I never even thought of that. I haven't tried it. I haven't done any benchmarks on it. All right, so let's do some slicing and indexing. There we go. A smidgen of that. Python lesson 3. Slicing and indexing, you guys. Print. All right. So A equals, let's see, what do we want? Let's do an A range. np.a range. Little quick and easy A range there. Print A. Run. Whoop. Hold on a second. We can close that window now. Okay. So let's give us some numbers. Now let's select particular elements from those numbers, right? Let's select more. Print A. And we're only going to select, say, like maybe, I don't know, the 5th element, right? The 5th element, the most important element. 5th element, which is a heart. We do that. There we go. The 5th element right there. Oh, it disappeared. Redo, undo, redo, redo, undo, undo, redo, redo, undo. There we go. Okay, 5th element, you guys. Right there, I see if something caught my attention. If I convert the coordinates in data 110 from the binary to decimal, you get 6. If I add 1, the element's position when all the values are serialized into a single row. Is that right? I see, yes. It depends on, are you summing it? Are you doing a sum? Like a sum? What do you mean? If I convert the coordinates in data 110 from binary to decimal, it's the same data either way. It's just how you're representing it on screen. It could be decimal, it could be binary, it could be hex. It's the same data. You get 6, but then if I add 1, I get, well, are you adding 1 as a binary value or adding 1 as a decimal value? I suppose it's the same either way. So the positions, you get serialized into a single row. I don't know. You'll have to show me the before and after. You have to show me the before and after. Take numbers from 1 to 100 and slice at every Fibonacci number. Ooh! Hey, is that a, what do you call it? What do you call it? I know what you're my brain's not letting me know what that is. It's called a thing. A puzzle. It's like a puzzle. Okay. Hey, Riddick, good to see you. Welcome on in. Sergio, happy Friday. Hey, man, Cardam Erdem, happy Friday. I missed your message there. Let's see. Novel as you expect linear, predictable results, and it did not deliver, right? Well, sometimes it doesn't, yeah. Hey, Silfopma, I missed your message, sorry. Riddick, hi, how are you? Okay, do you agree with most of Microsoft code is not good? I don't know. I don't use Microsoft, so I don't know. Will it be CUDA? Ooh, maybe we add some CUDA in here. Like maybe we can do a little bit of CUDA. All right, let me add that in here. Let's see, CUDA. It's on the list. Looking for golden ration. Oh, golden ratio. The golden ratio. Hey, yeah, I know about that. Let me sketch it. All right, sounds good. All right, 1 second, you guys. Yep, golden ratio. 1 second. It'll be about 30 seconds. I have to go click a button because the broccoli's ready. I have to go click a button. 1 second. BRB. All right, see, that was quick. We're back. Real quick and easy. Check out the 15-second hot take from Theo in general chat if you get a chance. Okay. Let's take a look at Theo. Making our way. Broccoli is good. I like broccoli. Yeah, me too. Me too. Fifth element, you guys, right there. Okay. Okay, let's look at general really quick. General. Oops. General. There we go. All right, let's pull this up.
We're currently in our skeuomorphic.
1 second. Let me pause the music.
Phase as software developers. We're pretending our terminals are the ultimate interface when they're not even good interfaces. And I'm saying this as someone who loves their terminal deeply. Natural language has no place in a terminal, but we pretend it does because the terminal's familiar. It's what we're used to. It's what we love. It's where we like to think of ourselves when we're thinking about coding. We're currently in our skeuomorphic phase as software developers. We're pretending our terminals are the ultimate interface when they're not even good interfaces. And I'm saying this as
we're in our skeuomorphic phase. Okay. Well, I don't even know what the argument is, really. Do you see this hot take for you? Well, here, this is what I say. This is what I always say. Check this out. This is important, you guys. Clock in. Use the IDE of your choice that makes you happy. You're going to have to type, if you're going to type anything on your keyboard, use the IDE that's your favorite. It doesn't matter if it's a terminal or VS Code or Sublime or Cursor or whatever, right? It doesn't matter. You could do whatever you want. It's the same thing. It really is. You know, you don't agree with this? I don't. Yeah, I don't. It's not an argument. It's just use what you're happy with. Because it doesn't matter at the end of the day. You're not optimizing anything. There's no optimization to be had. It's as optimal as it can be already. If you try to optimize it, it's diminishing returns, and you saved 1 second out of your entire lifetime. It's not worth it. Do you add curry to your broccoli? Ooh, that sounds good. I have before in the past. Usually I just eat broccoli raw. I eat it steamed raw. I know that sounds weird. But you guys, I'm old, so I have to take care of things. He's just selling his product. Yeah, maybe. Sounds about right. It's okay, though. It's okay. He gets to do that. That's his thing. He gets to do that. All right, here, I'll click the like button anyway. I'll click the like button. There we go. Optimal is intent-based. It has to be. Ooh, try CUDA C++ to fry your brain. Yeah, it will. Yeah, CUDA and C++. I've done it with the vectors, vec4, vec2, vec3. I've done it before. I might do it again. You never know. Theo says everything he pays for. Oh, even if he's claimed the opposite a week before? Yeah. Food, dude. Yeah, I could see that. You like that too? Nice. All right. Let's get back into it. Let's lock in, you guys. All right, so we're going to do some slicing here. So we're going to get the fifth element, which this will be like 4. Is that going to print out 4? Python, lesson, 3. Oh, it prints out 5. It does. It prints out the 5th element right here, right? So you 0, 1, 2, 3, 4, 5. The 5th element right here. Right there, the 5th element. Hey, look at that. I like me some 5th element right there. Okay, back to slicing. Not the cooking kind. Yeah, we're slicing. Let's slice away, you guys. Let's slice further. You can also get the last element. Last element. Run it here. Oh wait, by putting -1, right? -1 will get you 9. So it'll give you the last element in the list. So you can see 9 right there. The last element. Right there, a little bit of last element. And if you want, you can get the second to the last element by saying -2, right? Second to last. Save that. Which is gonna be number 8, right? Slicing it away. You can get a range of elements. Pose equals 1, 2. Pose 2 equals 4. 1, 2, foobar 5. Oh, yeah. Especially like this. Watch this. In Python, you can do some fancy stuff, right? You can do 1, 2, foo, dude, right? And then you can also grab start and end, right? So you can do this. So you can grab slices. This is slicing now. We're slicing it up. 1 to 2, right? And 2 to 2 is nothing, but 2 to 3 is foo. And 3 to 4 dot join. Can we do that? Can we do a dot join? Is that something we can do? No, we can't. We can't do a dot join, but we can do a join like this. There you go. Foo and dude. Foo dude. There you go. Foo dude 420. Let's do this. 42. 42. We'll say 5. Oh, it's a string, so we have to put that in a string. There we go. Foo dude 42. There you go. That is a little bit of slicing for you there. Just a smidgen. So this is accessing the element in the array, right? In your tensor. You can get the exact position. The exact position. If you want, though, you can get multiple positions, right? A 0 to 5. Get these positions here. A little bit of positioning. Just a smidgen of positioning. You like? I like it too. All right. Foobar. I like it. Get the index of a value. Yes. The index of a value. The value of an index. Where did you learn coding from? Sil. I learned coding many, many years ago. As at 11, I had a Sam's Teach Yourself C++ coding book with a CD, yeah, and it had the Borland C++ compiler on it. I put that into the computer with a CD-ROM tray, right? Remember those back in the day? You remember those CD-ROM trays? Whoa, flow state, hey! GCA, thank you for the flow state. My gratitudes to you. That's very nice. GCA, you are a wonderful person. You live alone? How you manage all the cooking while streaming? And also CTO. I do the simple. I put it oven and it's done. In the oven, done. Easy. That's it. That's all you gotta do. Put it in the oven. And it cooks itself. That's it. That's all you gotta do. Can we build a neural network from scratch? Yes. That is part of the plan. We are going to build a neural network. All right. Build a neural network. We'll do it again from scratch. Work from scratch. We will. We'll build it. It's gonna happen. We're gonna do it. We'll make it happen. We did it once before. We did it again a second time. We did it a third time. Will we do it a fourth time? Yes, we will do it a fourth time just for you guys. The DOM, we will make it happen. All right, so this is slicing. So we see slice 0 to 5 element, which is like, actually basically this is what it's called a slice. It sounds fancy. Don't worry, it's just getting a range of elements together. Basically, you're taking a vector, a tensor, a matrix, whatever, and you're getting just a segment of it. I want this to here to here, right? Just a little bit of slicing. Slice the first 5 elements. There we go. Right there. We print that. that will say 0 to 4, right? Because there's 5 elements. 0 counts as one of the elements. 0, 1, 2, 3, 4, 5. Wait, hold on. 1, 2, 3, 4, 5. Yeah, that's 5. 5 right there, you guys. Okay, where are we going from here? All right. So we can do more. It can go further. So you can do this approach, which is going to give us, what's that going to give us? The same thing. It's the same thing as 0. Slice of pizza, yep. These two are the same. Exactly the same here. It's kind of a neat trick. If you want to do that, you can do that. You don't have to. You can put it 0, but if you don't, you can do something else. You can also do a step. So let's see here. So let's slice it like this. So a step will give you all the elements, every even element, basically, right? Every even element or so, or essentially every other element. So slice every other element, right? So you can do stepping. You can step it up. A little bit of stepping there, right? And you can do every 5 elements, slice every 5th element. There you go. And as you can tell, there's only 2. There's only 2. Stepping, yep, you got it, Kyle. You got the right. Okay, did a sketch, hope it reasonable? I see, yes, did you put it in, you hope it's reasonable? Did you put it in Discord? Where did you put it? Let's see here. Okay. All right. Oh, hey guys, I use AI to program, but I'm mostly using AI for clearing my ideas so that I have a filter out if the possible, or the time waster, so I vibe code. Yes, but understand what you execute. Yes, retro, 100%. That's a good way to say it. That's a good way to say it. I like your approach. You have a slice of pizza to heat up. Oh, with corn, eh? Whoa, no way. You brought up a topic that we had at the beginning of stream. That's crazy. That's crazy. Hey, all right, bring in the corn. Corn and pizza, you guys. All right, so we got more we can do with slicing. We're not quite done yet. There's a little bit more we can do with slicing. So we can do, we can ask the answer to be a bunch of true or false, right? So if the value is greater than 5, return true. If it's not, then return false, right? So we can do a Boolean conditional slice, right? So that should give us true or false, I believe, right? Yeah, trues and falses. A whole bunch of true and falses, which can be useful to do dropout or a couple other things. There's some useful tricks here. No, good, no, corn, no corn. Hey, Harry, no, corn's great. I love corn. So you can use this as a mask. And this is a common practice that you use. So we can say the mask. What do we do here? So print A, where A is greater than 5, right? In general chat, sounds good. See what this looks like. Then that will only get you all the elements above, right? All the elements above that range. So if you want every element in your matrix to be returned that meet this criteria, you can do that as well. It's a pretty neat trick, right? This is why Python is amazing. Right there. That's why Python's amazing. Failure is the best way to learn. Yep. With AI, that means money. Unfortunately, you're directly trading money and certainty for speed. That's a good point. You don't need to do that anymore. You don't need to learn it. You could just have the AI, spend money on the AI. Whoa! Hey, we got some AI generated goodness here. Okay, so what do you got here? Let's take a look. All right. So ICS. What do we got here? Oh, let data. 3-dimensional cube. Yep. Data slice row column. Yeah. Row column. 2 slice, 2 row, 2 columns. Visually represented. 7. Okay, so you've got a 7 here. This is pretty clever. This is what we're doing right now, you guys. This is what we're doing. We are messing with tensors. Let's see here. 7, 8, binary intuition special case. Position is flattened to order. 6 plus 1 equals 7. Let's see here. So the position is the 7th element. 1, 1, 0. So it'll be 1, 1, 0. Column 1, column 2, row. Okay, right. So the first, and then the first row, and the 0. Okay, yeah. So yes, we get 7. So we index 1, right? Which is going to be this slice, not this slice. This is index 0, index 1, and then column, row 1, right? Because it goes row, slice, row, column. Slice. Okay, yeah. That part makes sense. Yo, I haven't tried slicing in tensors. Yeah, they do a pretty good job. I like it. I like them tensors. All right. Okay. 3D and 4D. Yes. Binary intuition. So this part, I don't know what's going on here. Position in flattened order. 6 plus 1 equals 7. So this position is the 7th element. Flattening. You can flatten the whole thing. Oh, interesting. So data corresponds to position 7 in the flattened row. Yeah, so there are approaches that you can do to flattening. You could do that too. Nice visualization. Yeah, that's from ICS. ICS made that visualization. It's pretty neat. I think it's a pretty neat approach. Position is flattened in 6. So the position is the 7th element. 1, 2, 3, 4, 5, 6, 7, 8. There we go. That's how it would flatten. So ICS, what was your question though? Something caught my attention. If I convert the coordinates data from binary to decimal, I get 6. If I then add 1, I get the element's position with all the values are serialized into a single row. Oh, to flatten it. Is that what you're doing? You're just flattening? Okay. Well, it looks like you did a good job. I mean, that's what you're supposed to do. You did it. You did a good job. Yes. All right. Very nice. Hey, that's great. Yeah, people are praising you. They're saying, good job. What's that you didn't really need to implement the entire function in your script or program? When I started programming, I was younger. Yeah, AI wasn't a thing yet. Main too. I used bugs to ease my work. Wait, what do you mean ease your work? I think that could be something you could do. All right. What do you use to make automatic captions in the video? Oh, hey, Yubi. All right, so these here, right? These live captions. This is something I wrote many years ago. Do I have that up here? Did I leave it? All right, so what you do is type Twitch OBS subtitles Stephen LB. I'll put it into our Discord so you can see it. I'll add it into our Discord, you guys. So this is subtitles. Really, they're open captions. It's software that I wrote 8 years ago, right? Find 8 years ago. And it works really well, as you can see. It works really well, right? It gives you the option to have subtitles that, span the screen and more than one word comes on the screen at a time. You could do that. Or if you want, you can have the one word at a time, just like this. And you use this pattern here, right? You use this pattern right there. So then you can have open captions right there on your stream or on your Zoom. It could be on YouTube. It could be on Twitch. It's wherever. I'll send this over to our Discord link share. Link share. There you go. That's available for you for free forever. Give your whole stream stack. It would be really helpful for the future. Well, I mean, it's a really simple stream stack. There you go. It's just OBS. That's it. It's OBS. Yeah, OBS and subtitles. That's right there. OBS and subtitles, you guys. It's real simple. All right. Thank you, Kyle. Thank you for the link. All right, you guys. So let's see if we can finish up slicing here really quick. All right. Let's finish up some slicing, you guys. All right. So you can also use columns and rows. So just like ICS was describing, you can describe your columns and rows using comma notation, right? So you can say print A, and if we do, let's see here, how do we want to represent this? We need to do a multi-dimensional. We need to do multi-dimensional, right? So m equals np.arange. There we go. Thank you for the hearts, you guys. That visual was extremely satisfying. It was, right? That's from ICS. General. Right here. I think it's great. See, ICS, they agree. They like it. I think it's great. So let's see if we can access some of that stuff, right? So can we do a, how do we do this? 2 by 2, can we do that? Let's see, 2 by 2, print m, run really quick. Where did we mess that up? Line 25, you said? 25. Oh, whoops. There we go. There we go. Okay. 0 to 2. Okay. So can we do 2? Yeah, that's what I thought. Okay. Let's maybe do a line space. How do we want it? Let's do, what is it? A range. What's a good A range here? 10. But I want to do a 10 by 10. So let me do a 5 by 5. Can we do that? Something we can do? Doesn't want it. A range scalar arguments expected instead of a tuple. What about linspace? Right? Remember linspace? Let's see here. I would love it if it worked here. 0. So that's 0 to 5. No, that's going to be... I suppose what we could do is we could do 2 A ranges. Let's do this. A range, like this. And then we'll say... Whoa. How do we want to do this? We'll do 10. Yeah, we'll do 10. Say np.array. There we go. All right, put this in here. There we go. Thank you for the hearts, you guys. Appreciate it. I'm setting up for the next lesson part here, and then we'll wrap up. We're nearly done. Okay. Let's see, is that too much? Is that too big? No, that's good right there. That's good. Okay. So now we have a 10 by 10 matrix. 10 by 10 matrix. And we can start indexing them by columns and rows. Just like in this visualization that ICS gave us, we can do some indexing in different ways, I believe. So print m, say 5 and 5. Right, so that's going to give us, oh wait, that should work. Index out of range? No, it's not. Wait, no way. Oh, right. 1 by 5. Okay. So we need the first range, 10 by 2. Saying 10 by 2 dom. 10 by 2. A little bit better. 1 by 1. There we go. So what happens here? 1 second. Let me hide this. Let's print this out. Print it out. Okay. Why is this? Oh, setting array element sequence requested array shape dimension 1 detected. It's non-homogeneous, so we need to keep them homogeneous for this example. It's got to be the same. We could do a 2 by 2 by 2. Ooh, a 2 by 2 by 2. All right. Invention of 2D array behaviors. The invention. Yeah, the invention. All right, let me get set up here, you guys. How do I want to show this? I suppose we can just say, yeah, okay. I think this is good enough. Here. So let's print this. There's a couple ways that you can index these guys and slice them. So you can grab the 1 by 1, which is going to get the first, but we could also increase this, right? So we can increase this by 10 plus 10. So let's do that really quick. Okay, so we have 0 to 9, 10 to 19, right? So then if we want to get this element right here, we say this, the second matrix, or the second tensor, and the second value in that tensor, which will be 1 by 1, right? And 0, 1, 0 will be 10. This will be 10, right? This will be 10. This is 11. 11, right there. So that's 10 and 11. So we should see 10 and 11 here. Like that right there. Some 10 and 11. You had to correct so many weird edge cases in the AI that you would have been addressed if you were thinking about the code independently. Oh yeah. It's like sort of like shepherding the AI. It's like, oh, do this, and it kind of goes off track, and you're like, no, go this, and it goes a little bit off track over there, and you have to like shape it back and forth. Do you plan on working Common Lisp one day? Oh, Lisp! You want the curly braces? You want the parentheses everywhere? You want to do some parentheses? You guys know what Lisp looks like? Lisp, so Google Lisp programming language. Look at that. A little bit of Lisp programming right here. We have an example. Parentheses. We got some more parentheses. Oh, you want more? We got some parentheses there. Oh, I got a lot of parentheses for you guys. You meant the output is a 10 by 2 matrix. Oh, yes. Thank you for your correction. Dadom. Hey, gold star for you. Paying attention in class. Yep, you're right. 10 by 2. Good job. Good job. Thank you. Yeah, it's not a 10 by 10. It's a 10 by 2 because there's only 2 rows, but 10 columns. Good. Dumb. Gold star. The dumb. Thank you. Thank you very much. Yeah, that would have been a mistake. Whoops. So you can also print, I believe, you can say comma, I think, right? To make this a little bit easier to see. So you don't have to have so many brackets everywhere. So that's a little bit easier to read. I think that's going to be 10, right? Let's see here. Let's bring this back here. Yep, that's a 10. So this allows you to do this notation, which is a little bit easier to deal with, right? That notation is a lot nicer. So use the comma notation to slice. You can also slice using everything to get all the data. So all the data for that slice on the second. That looks like that. Do 1. So everything between both, all the columns will get included. Since it's a 10 by 2, you'll only get 2 values. And I want the second value. So this will be, let's go 0. So let's bring this down to 0. 0, 0. This will be 10 by 2, 0 by 1. 0, 10 is the answer. And then if we do an increment by 1, then we're going to grab only these elements here. All right, let's grab here Verge V. There we go. So if we grab the seconds, it'll be 1 by 11. Right? That's 1 by 11. And then this will be 2 by 12. If we increment this, 2 by 212. Right there. Hey, matrix representation is row X column. So it will be a 2 by 10. Hey, Rox, I was wondering if anyone was going to point that out. I was wondering. Rox, there you go. At Rox, gold star. Very nice. Gold star. Thank you. G-O gold. How many did? There we go. Gold star. Very nice. All right, you guys. Thank you for the corrections. Making it right. So if we run this program now, we should see the outputs as we've described earlier. Hey, how's it going there, Francois? Yo, Francois. How's it going? Long time no see. Welcome on back. Good to have you here. Francois here, you guys. Francois, how was your day? Did you have a good week? Hello. So that's slicing and indexing, you guys. That's slicing and indexing. We did it. That concludes lesson 3. All right, you guys. Lesson 3 done. What is going to be lesson 4? Let's find out. Let's see what lesson 4 is going to be. Let me scroll to the next song, you guys. Here we go. Lesson 4, getting started. All right. Lesson Got star, send star. Hey, there you go. 0, 4. We're gonna do aggregations. So like things like sum, min, and max, things like that. A little bit of things like that. Lesson 4. Right there. Amazing week. Just finishes my professional Docker certification on LinkedIn. All right, Francois. That's great to hear. Congratulations. All right. So, thank you for the party poppers, you guys. Good to have you here. Thank you very much. How do I do this LO sending a star? Oh, yeah, it's a good question. Great question. Yeah, this is exactly what I was hoping for. We figured it out, you guys. We figured it out. Maybe we did. Maybe just a little bit. The star. Thank you for the star. Very nice. Okay, so now let me commit this. Get status. Where did we leave off here? Get status. Thank you for the hearts, you guys. We are get add here. Get commit. AM. We added lesson 03. Done. Push to main branch. All right. So we grab this over here. Go to link share. And it is available here on the source code if you want. The first 3 lessons complete. First 3 lessons complete. We did it. Okay, you guys. So good to have you here. Yeah, we did it. Success. Perfect. All right, that's what I was hoping for. All right. Great. Gloomy traffic. Yeah, we did it. So tomorrow, we will be continuing with our more aggregations. Maybe later today we'll do a second bonus stream, and we'll continue on from there. Or tomorrow morning we'll continue from here. So we got aggregations next. That'll give you the introduction. I know this is like the easy part. And then after that, lesson 5. What are we gonna do in lesson 5? I'm gonna open my notes really quick. I got lesson 5 here. We'll do some linear algebra, which sounds hard, but don't worry, it's not. It's gonna be great. We should decide the pace for this. How fast are we going? Fast enough, you guys? Are we going fast enough? All right. So thank you for the reactions. Let's give a poll here. All right. Pace. Let's do a pace here. Start a poll. All right. Let's see. What's our pace? How fast should we go? The pace for ML introduction course. Right? Slow, medium, fast, very fast. Okay, we could choose that. What do you guys want? Francois, I have deployed your first ML model with fast API and UV-corn. All right, just like you told me to. Hey, that's great to hear. All right. I think my brain's fried. Can I quit and start from a farm? Yeah, you can do that. You can. People are doing it. Hello, how's it going there, Tebu? Hey, Tebu, welcome on in. Good to have you here. Happy Friday. Gloomy, just fast enough that the gradient descent can keep up. Yeah, it's going too much faster. The AI, it won't work. It won't. It'll have problems, you guys. It'll fail. It'll be like, error, not fast enough. All right, so you guys want medium fast. You want a little bit faster? Okay. Just a smidgen faster. I see what you're doing over there. Okay. All right. Good to hear it. So our next lesson will be in aggregations. Let's try going fast on this one. We'll try going fast. What's everyone gonna build? I don't know. That's a good question. What are the exciting projects that you guys are working on right now? Farming, grinding, millionaire farming. Hey, Rox, there you go. You figured it out. That's the way to do it. All right, let's try lesson 4 really fast. We'll try lesson 4 really fast. Some aggregations, yeah? All right, so we're gonna do summing, unmaxing, and argmax. All right, let's try this. Lesson 04. Pi, there we go. import np numpy as np. We're going to say a equals np.array. We're going to do like simple array. Make it easy. Real easy. 1, 2, 3, 4. All right, we'll do just 3, yeah. And then we will do another one. We'll say here 4, 5, 6. There we go. And 6. Perfect. Okay. So that's an array right there. Little easy array. Let's print that out. Print A. So this is going to be aggregations. Okay. All right, you guys. Health service, what are you working on? Oh, yeah. Nice. Keep track of driving trips. Oh, diving trips. Oh, wait, no way. Logbook, finishing machine learning project. A health cancer survivor as a bachelor thesis. That's great. That's fantastic. You want to look at AR, UVIs, image analysis, games. Hey, Kyle, you guys are building exciting things. Python, here we go. Let's load that. Let's see, close that. Python lesson 4. Wait, oh, we didn't save it yet. Save that. Is that, oh, whoops. Okay, hold on a second. I typoed it. Here we go. All right, mv dot to lesson 04. Invalid argument. Right, okay. Can we do backslash then? Oh, we can't, okay. All right, no big deal then, no problem. We can fix this. Python, let's see, lesson 04.py. Paste. There, easy. Easy. A little bit of cheesy easiness there. Okay. Oh. Comma. Add the comma. Whoops. Okay. Have you tried IPython or BPython alternative? I've tried PyPy. PyPy and what is it, like Iron Python? I've done those. I've tried those before. Grants applying for another use, AI in healthcare. Hey, Gloomy, nice! Some of these tips for some going into the last year of data science, but with great interest in machine learning ops. AI engineer with software engineering skills not being your strongest. Oh, okay. Well, if you want AI, you're already on the right track. I think that's a good track you're on. You only tried CPython? Yeah, PyPy is a good way to like accelerate PyPy. A little bit of PyPy in there, which not to be confused with PyPy, which is the package management system. You would have to sign NDA for me to tell me. Okay, all right. It's understandable. No, the Python shell alternative. Oh, the REPL. Oh no, I haven't. I've not tried a Python alternative REPL. I have not seen it. Okay, so a.sum, it's an aggregation right there. We're speeding up, you guys. We're speeding up. 21, right? You could say a.max, right? A little bit of maximum in there. So that should be 6, right? 21 and 6. Then you can also get the average, mean, right? The average 3.5. You can also get the sum of the axis on the axes. So you say axis equals 1. So just sum these guys here, right? So 4 plus 5 is 9, right? So 15. Should this be 15? This should be 15, maybe? Yeah, there we go, 15. And 6 for that. So 15 and 6. And then you can also do argmax, so it's going to give the biggest value across both arrays. Argmax, right? And that will give you the two values, right? Oh, it only gives you 5. Okay. 5, that's weird. Argmax should give you the biggest value. That's odd. I thought that was going to give you a really big value. Index, oh, it's the index, right? Okay. It's the index of the largest value. Right. The index of it, right? 0, 1, 2, 3, 4, 5. So it's going to give you the 5th. See, index of the largest value, So this is great for logits. When you're dealing with logits, which is the output, typically an output on most AI models, it's going to give you basically the classification. And you can have lots of classifications. A classification even can be a letter, right? Or a number. Number 1, 2, 3, 4, 5, A, B, C, D, E. Those are classifications. You can also have like animals like cat, dog, bird, those sorts of things. Or you could have colors, red, green, blue. So this is where argmax is going to be useful. And then what else? That's it. Okay, that was a speed run. That was a speed run of aggregations. That was lesson 4. Was that too fast? Okay, so you want medium. Okay, so I think we went a little too fast that time. You're on the right track. Good. Yeah, I know where to go exactly right now. You don't know where to go exactly right now. Do ML ops, data cleaning, those kinds of efforts are pretty big amounts of work. So if you could apply to AI studios to do data management, that might be a good next step, right? Because it's an entry level, it's a foot in the door. It is still difficult to get that job though, because a lot of people are applying. Can you explain L1 regularization? So let me see. I could. Let's find out. Let's see. Google L1 reg. I know. All right. So when would you want to use this? When would you want to use it? One of the problems is overfitting, right? Overfitting in your AI model. In order to prevent that, you can change the shape of your gradients in your model with L1. Cool shirt. Hey, thank you, Sergio. Appreciate it. Yeah, this is the, where is it? Here? Okay, yeah. I don't know if you can see that very well on the screen. I don't know if that shows up or not. It's a shirt from Twitter when Twitter used to be Twitter. It's really a Twitter shirt. Is there anything on the back? Yeah, there is. You can kind of see on the back, yeah. I don't know if you can see that or not. But yeah, it's a Twitter shirt. That's a Twitter shirt. Francois, thank you. Yeah, absolutely. So L1 regularization, regularization. Let's see if you typed that correctly here. So L1, all right. Often called lasso regression, is a technique used in machine learning to prevent overfitting. See, I know what we're talking about here. I know what we're talking about. It works by adding a penalty equation into the absolute value of the model's coefficients, which are just the numbers, right? Coefficients are numbers, right? To the loss function. Okay. So this modifies the model's, works by adding a penalty equation to the absolute value of the model's coefficients. This drives less important feature weights to exactly 0, resulting in a sparse and easy to read model that automatically performs feature selection. Okay. So we sum all of the weights or the coefficients, right? We sum them and we grab the, is that a delta? Plus the loss. Okay. So we're literally just adding a number to the loss directly. Is that all that is? Is that really all it is? Where loss of the original error, mean squared error, is the regularization parameter controlling the penalty strength represented in the model. So you just sum all of your coefficients and then you add them together. But that seems like a really big number. That could be a huge number. Or getting an Ori shirt on my contributions. Free clothes, Harry! Free clothes! Yeah, Twitter flight written on the back of your shirt. Yeah, that's crazy. I remember that from the day. That's crazy. Yeah, many years ago, you guys. Lambda. Francois Lambda. I like me lambdas. I do. I like my lambdas. It's been a lot of time I forgot. Yeah, it has been. So it's actually pretty straightforward, isn't it? This is pretty straightforward. When to use L1 versus L2. L1 zeroes out coefficients. L2 squares the coefficients, squares them to shrink them without ever reaching 0. Got it. Okay. I'm getting blown up on my text messages, you guys. What have we got here? Let me zoom in on this really quick. Let's see what we got here. Oh, cool. Also, research lab. Oh, wait. Oh, hey, look at that. I didn't even know. Check this out. I'm also a major research lab. The problem. Hey. All right. So apparently, I've been in contact with one of the people. You probably heard of them from maybe Anthropic or OpenAI Research Lab. They're just talking to me right now. I didn't know that they worked there. That's crazy. That's crazy. All right. That's amazing. I didn't know I know that person. All right. Now I'm in contact with someone at the major AI studios. Hey, I didn't know I knew that. All right, you guys. All right. Great to have you here. I think there was an elbow method related to this. Was there? Thank you for the party poppers. We're doing pretty good. Maybe do a video now on free open source clothes so we can merch. You can get, hey, Harry, yeah, exactly. You then do the gradient on the loss plus the new term. Yes. So you grab the loss, which is going to be just a float point number, right? And then you add another number onto it that's going to be offset of the average of all of your weights. So you take all of the weights or your coefficients or your parameters, you add them all together and you add it to the loss. That seemed a bit much. It seems a bit much. You know what? That seems fine though. Seems good to me. All right. We're going to zoom out there a little bit. Users discuss trade-offs. Would you know here? While L1 zeros, squares coefficients. Okay. All right, that's enough regularization talk. Yo, Sergio, thank you for the GGs. All right. Sergio, appreciate it. Thank you so much. My gratitudes. You guys are fantastic. That's so much fun spending time with you. Sergio, how you do it? Sent a star. Yeah, you guys, this is great. All right, so we'll go medium speed for the next lesson, which we need to start tomorrow. We got to start that tomorrow, you guys. So we'll do medium speed lesson tomorrow. We're going to start with, let's see what the next lesson is. So let me get this set up here. So we did lesson 4, aggregation, just now. And then lesson 5, which will be tomorrow, lesson 05. What do we have on track? So we are going to do dot product. All right, we'll do dot product tomorrow, which is really easy. A little bit of dot in there, just a smidgen of dot. We're just going to do some matrix multiplication, yeah? A smidgen of matrix multiplication, which is the whole idea behind modern AI. A little bit of matrix multiplication. You're doing CS, but going AI engineering path. Hey, great to hear. Hi, Stephen. Good to see you. Mohammed, hello. We're wrapping up, you guys. I got to head out now. I got to go take care of a lot of things on my plate. My next achievement is learning Git and GitHub because they never reached me in the university. Yeah, that's one of the things. The good news is it's really straightforward. Git add, git status, git commit. Oh, wait, hold on. mv dot space lesson to, wait, how about we just rm that? Okay, here we go. Git add, here we go. Status, git commit am, lesson 4. Done. Git push origin main. Those are the common commands right there. Git status, git add, git commit, and git push. Good to go. You did it. What's the difference between array and tensor? They're the same thing. They're the same thing. They're the same thing. But a tensor can be any kind of shape of array, right? A tensor can be a scalar, it can be an array, it can be a small array, or it can be a multi-dimensional array, right? You can do multi-dimensional array. So this is a tensor. Tensor can be anything. It's like any number. Any number. Tensor is a number or array. That's what a tensor is. An array is just going to be an array, right? It's always going to be some set of values, right? That's the difference. A tensor is everything. And you can have rank 1, rank 2, rank 3 tensor. And then you can have a matrix, which is a low rank or high rank. What are pre-learning before this? Pre-learning. Okay, so if you weren't here at the beginning of today, we did creating tensors, using tensors with math, indexing and slicing, and we did some aggregations. Tomorrow we're going to start dot product and linear algebra. I do it in the main folder project. Yes. You got it, in the main folder, yes. So you type git init to start your repository, and then git add dot to add all your files, and then git commit am, and then you type a message. There you go. And then you've committed it. Then you want to push it to a remote. Hey, Laura. Yeah, you're late. Oh, Laura. Oh, no. We're wrapping up now. We got to get out. We got to go. It was great to have you guys here, though. Yep. Oh, good luck, givers, takers. Good day. Hope you're well, sir. I am. We're doing good. Haydar. All right. What is the time there? Here it's 11. It is 10:45 a.m. But I got to get going. I got work to do. Is it automatically connected to GitHub? You have. Oh, you're so nice. Hey, thank you. You're very nice too. What program is this, Paul? This is. We're doing Python Introduction to Machine Learning. The code that you see on the screen is Ghosty plus Tmux plus Vim. Those are my text editor of choice. That's what it is. Bye, guys. All right, we'll be back. Thank you guys so much for joining. We'll be doing more Introduction to Machine Learning in the next episode. Okay, thanks. Cool. Have a great day, everyone. See you later. Bye, guys. See you next time.